Let's take a look at problem 5. If concentrated HCl is 37.2 by mass, and the density of the solution is 1.19 grams per milliliter, what is the molarity of the concentrated solution? So molarity, remember molarity is moles of solute over liters of solution. Okay, now I'm not given a mass of solute or a mass of solution, and I'm not given a way to really calculate the mass of solution either. I'm just given a density. Therefore, because I'm not specifically given the mass of either, I can make an assumption here, which is a valid assumption, but I can assume the mass of both from the percent that I'm given. What does that mean? Well, if I have a 37.2% solution of HCl, I can assume that I have 37.2 grams. So my percent by mass tells me that if it's 37.2%, it tells me that I have 37.2 grams of HCl over 100 grams of solution times 100, and that gives me 37.2%. Okay? Now, this is true when I'm not given a mass of either the solute or the solution. I mean, this is true all the time, but if I'm specifically given those values, then I have to use those values. If I'm not, then I can always assume 37.2 grams over 100 grams. If I have a 13.4%, let's say, that solution by mass, what that tells me is that I have 13.4 grams of solute over 100 grams of solution. If I have a percent, 6.2% by mass, that means I have 6.2 grams of solute over 100 grams of solution, etc., etc. So because what happens is, to give me 37.2% here, I am dividing by 100 grams of solution, but I'm also multiplying by 100 to make a percent. That 100 cancels, leaving me with a top number, so that I can assume whatever the percentage is, I can assume that this is the amount of gram of solute over 100 grams of solution to give me a percent. Okay, this is just to simplify our problem here, to simplify our math. Otherwise, we wouldn't be able to calculate any of it unless we're given an amount somehow. So this is true, and therefore we can use it as a relationship. So we have 100 grams of solution, and I have, to find the molarity, I need the moles of solute over liters of solution. To figure out the liters of solution, now that I have a mass in grams and I also have a density, I can calculate the volume of the solution. So I know that my volume is given as the mass over the density. My mass is here because I already assumed 100 grams over the density, which is 1.19 grams per milliliter. My grams will cancel. This will go up on top, and it's 84.03 milliliters. Now, I have to take it one step further because the formula for molarity is in liters. That means that 1 liter has 1,000 milliliters. I have to divide it by 1,000. And my volume turns out to be 0.08403 liters. That's my volume. Okay, now I have a volume. I need to figure out the moles of solute. Once again, I assume 37 grams of my solute over 100 grams of solution. So this is the amount of my solute. I can convert that to moles by using the molar mass of HCl. So the moles of solute are given as 37.2 grams multiplied by the molar mass, which is, so 1 mole of HCl weighs 36.46 grams. My grams will cancel, so I end up dividing by the mass in grams, and then I have the moles left on top. Okay, and that gives me 1.02 moles of HCl, of solute, which makes sense, right? One mole weighs about 36.5 grams. I have 37 grams, so it's just a little over 1 mole. And now that I have both pieces, I have my moles and I have my liters, I can figure out the molarity, moles of solute over liters of solution. Okay, which means I have 1.02 moles. Divide that by 0.08403 liters, and that gives me 12.14 molar. That is the molarity of the solution. Once again, the trick here was to get the mass percent to express it in terms of 100 grams of solution, so 37.2 grams of 100 gram solution, to understand what this mass percent tells us. You can assume this if you don't have neither the mass of the solution nor the mass of the solute. This is always true, but because we're given some amounts in other problems, we were given amounts, and so we had to use those amounts, but this is always true for any of the problems that we already did. So, you know, the first problem was a 4% solution of NaOH, which means I can have 4 grams of NaOH in 100 grams of solution. That gives me a 4%, etc., etc. And once you know these two values, then you can just go ahead and calculate the rest. Always remember the units, because they will tell you, and remember not just moles per liter, but moles of solute per liters of solution, because they will guide you as to what you have to calculate. Okay, I am going to erase this, and then we'll move on to percent by volume problems.